Hello, welcome to our channel. In this video, we will talk about evaluating and graphing functions. So we can think of functions as machines where they have input and output. We generally denote input by variable x. And if we run that x through machine f, then the output, we call that f of x, which is some number. And we generally denote this by y also, f of x or y. So for example, we can consider this machine as an squaring device. So if you input any number, this machine will square that number and give you the output. As the first example here, if you input 3, then it will square that 3, make it 3 square and give that as output. So that means f of 3 will be 3 square, which is 9. Similarly, if you input -3, it will square -3 and give the square of -3 as output. So square of -3 is also 9. So also for -3, the output is 9. If you input 5, it will square 5 and give you 25. If you input a, it will square a and give you a square, whatever a is. If you input x, it will square x and give you x squared. Here is another example. In the previous one, we had f as squaring, but in this case, we have it much more complicated. So if you input x, the machine will take that x and do this operation, this algebra, 2x plus 2x over x squared plus 1. So basically in that diagram form, if you input x, then you will get 2x plus 2x over x squared plus 1 if this is machine f, this particular one. So if you input 1, so this machine will take that 1 and give you 2 times 1 plus 2 times 1 over 1 squared plus 1. So whatever that number comes out to be will be the output for input 1. So it will look like 2 plus 2 over 1 plus 1, which is 2. So the output is 3. If you input 5, you get 2 times 5 plus 2 times 5 over 5 squared plus 1. So 10 plus 10 over 26. And again, whatever this number comes out to be. So if you want to combine these two, let's simplify this before combining. So 10 plus 5 by 13. We want to have the same denominator, 13. So the first one you can write as 130 over 13. And the second one is still 5 by 13. So this will be 135 by 13. The output for 5 is 135 by 13. When the input is b, it will do the same thing as it did to x. So it will take that b and multiply that by 2. Since we have 2x here, so we'll have 2b plus multiply that b by 2 again and divide by b squared plus 1. If you input b plus 2, it will multiply that b plus 2 by 2 over here, plus 2 times b plus 2, divide by b plus 2 squared plus 1. And the rest is just simplifying. We can simplify this a little further maybe. So it will look like 2b plus 4 when you distribute that 2, plus on the top here we have 2b plus 4 again, divide by, we can try to simplify this. So b squared plus, if you square that, you should get 4b plus 4 plus 1. And you can combine these two as 5. So you can do that simplification. The last example here, we have 5b as input. So the output would be 2 times 5b plus 2 times 5b over 5b squared plus 1. So we just replace all x's with 5b. So this will look like 10b plus 2 times 5b over here is 10b. Divide by 5b squared will be 25b squared plus 1. So this is the output when input is 5b. Now let's talk about graphing functions. So to graph a function, we just look at all the order pairs, x and f of x. So basically graph of a function contains all the order pairs, x, f of x, for each value of x in the domain. Let's look at some examples. So here is the first one. Create a table of values of x and f of x. To sketch graph of this function. So we have a table like this one. Of course, there are infinitely many possible values of x. X can be any real number, but let's just look at a few of them. So let's consider 0, 1, -1. Let's just look at some nice numbers, 2 and -2. So when x is 0, we have 0 squared plus 1, which is 1. When x is 1, we have 1 squared plus 1, which is 2. When x is -1, we have -1 squared plus 1, which is 2 again. When x is 2, we have 2 squared plus 1, which is 5. When x is -2, we have -2 squared plus 1, which is again 5. So let's try to plot these points. From the first line, we plot 0, 1, which is a point right here. From the second line, we plot the point 1, 2, because x is 1, y is 2. So 1, 2 is right here. From this one, we plot the point -1, 2. -1, 2 is right here. From this one, we plot the point 2, 5. 2, 5 is right here. Here we have the point -2, 5, which is right here. And if you get more points and try to connect them, the graph will look like this one. We'll keep going on both sides. So this is the graph of this particular function. Let's quickly see how we can do this in a TI calculator. So in your TI calculator, hit the button y equals this one over here. And then you can just enter the function now. So we have f of x equals y squared plus 1, which is same as saying y equals x squared plus 1. So we have f of x equals x squared plus 1, which is same as saying y equals x squared plus 1. So we'll enter x squared plus 1 here. So for x, we can use this button here. This will square that. And then plus 1. Hit enter. So once you do that, then we can just hit graph. So it looks like we need to fix the window. The graph may be outside the window that we have here. So hit window button. For x minimum, we can use something like -5. For x maximum, we can use 5. For y minimum, let's use -5. And for y maximum, let's use 5. So let's try to use this square window. Now again, hit graph. Okay, so this is the graph of the function, and which looks exactly like what we got when we drew by hand. Right, so let's look at another example now. So here we have the next example. So we do the same process. Again, we create a table of values of x and f of x, and then plot those points. So we have x, and f of x. So when x is 0, we have f of x to be 0 to 4 minus 0, which is of course 0. When x is 1, let's list the values of x we want to try. So let's try -1, let's try 2, -2, and we have space for 1 more. So let's try 3 also. So when x is 1, we have 1 to 4 minus 1, which is 0 again, because 1 to 4 is 0. When x is -1, we have -1 to 4 minus -1. So -1 to 4 is 1, minus -1 would be +1. So that gives us 2. When x is 2, we have 2 to 4, which is 16 minus 2. So we get 14. When x is -2, we have -2 to 4, which is again 16, minus -2. So we get 18. And when x is 3, 3 to 4 is 81, minus 3 would be 78. So from the first row, we have the ordered pair 0, 0. From the second row, we have ordered pair 1, 0. From the third row, we have ordered pair -1, 2. From this one, we have ordered pair 2, 14. From this one, we have ordered pair -2, 18. And from this one, we have ordered pair 3, 78. So these are the points that we want to plot. Right? So if we look at the values on the y-axis, here they go from -5 to 6, but we have very large values over here. So 2 is fine in this range, but we have 14, 18, and 78. So let's try to fix the values on the y-axis a little bit. So maybe we can go by steps of 4. So let's do 4, 8, 12, 16, 20, and 24. And let's do the same thing here. So -4, -8, -12, -16, and -20. This 378, this y value 78 is still outside the range, but that's okay. We will just not plot this one. So 0, 0 is right here, the first point. 1, 0 is right here, the second point. -1, 2 is somewhere here. So -1, 2. 2, 14. 2, 14 would be somewhere over here. Done with that one. -2, 18 would be here. Sorry, -2, 18 will be up here. All right, so these are the points we have from the table. And this 378 will be somewhere up here. So 3 and 78 will be somewhere up here. So if we look at these points, I believe the graph will look like something like this. And to graph it more accurately, we need more points and we need a lot more information about this function. Just by looking at these points, we get the overall idea about the graph of the function. All right, so now let's try to graph it in a TI calculator. So go to y equals, and we can clear that function that we had in the previous example. So we have x to 4, x, and then to write exponent, we can use this key here, this caret key, 4. Then we have minus x. So this is the function, hit enter. And now go to graph and see. Okay, so this is how we got when we drew by hand also. So it looks quite similar to what we have here. Here is the next example. We have x squared over x plus 1 Again, let's create a table of x and f of x. So when x is 0, we have 0 squared over 0 plus 1. So 0 over 1, which is 0. So we have the point 0, 0 from the first line. When x is 1, we have 1 squared over 1 plus 1. 1 plus 1 is 2, and 1 squared is 1. So we get 1/2. We have the order pair 1, 1/2. Now let's try x equals -1. We have -1 squared on the top, -1 plus 1 in the denominator. So -1 squared is 1, and in the denominator we have 0. But we can't divide by 0, so this is undefined. This means -1 is not in the domain of this function. We can't have a point like -1 and some y value. Now let's try x equals 2. We have 2 squared over 2 plus 1. 2 squared is 4 over 3. And let's try -2. -2 squared is 4 over -2 plus 1, which is -1. So -4. So here we have the order pair 2, 4 by 3. And here we have -2, -4. Okay, so these are some of the order pairs that lie on the given function. And of course, to graph this function accurately, we need a lot more points. But let's plot these points and see how they look like. So when x is 0, y is 0, we have 0, 0. When x is 1, we have y is 1/2. So 1, 1/2 over here. When x is -1, the function is undefined. So there is no y value when x is -1. When x is 2, y is 4 by 3. 4 by 3 is little over 1, so maybe somewhere over here. And when x is -2, y is -4, this point here. Again, just by looking at these points, we can't really say how the graph looks like. But if you get a lot more points, then I can tell you the graph is going to look like this one. So going that way here, and you have one more piece over here. So this is the graph of this function. Now let's use our TI calculator. Again, go to y equals. Let's clear this function that we had from the previous example. And then now we need to enter this function. So we have x squared. We can use that button for x squared. We have divide by x plus 1. So we want to put that x plus 1 in parentheses. X plus 1. So this is the function. And hit enter. Now let's hit graph and see how the graph looks like. So this is very similar to what we got over here. And if you want a better view, we can adjust the window a little bit. I think the x values are fine. We can start y value from like -10 maybe. Let's see how that looks like. Let's go back. We'll go to window again. The y mean is -10. So when you enter that negative, we need to use this negative sign over here on the last row, -10. Right, so graph. So this is the graph of the function. So this is all I have in this video. We will work on a lot more functions and examples in our next videos. Thank you for watching and have a great day.